Well, hello everybody. What I need to do with you today is I need to cover section R-1 and R-2 out of our calculus book. Not very hard sections, to be truthful. I just need to review factoring with you and then polynomials. I didn't even type up section R-1. I didn't even type that up because I think it's pretty easy. I got 5 or 6 examples is all. So you will need your class note sheet in front of you. We'll start doing that right when I get to the factoring part. So what I'm going to do is I'm going to cover section R-1 with you. Guys, all it is, it's over adding, subtracting, and multiplying polynomials. This will look really familiar to you. So here goes. I need to review with you that when you add polynomials, you simply find your like terms and add or subtract them. So in this case, when I simplify here, I'm going to have 11x cubed. Let me mention, whenever you add or subtract, powers do not change. Here's a squared term, there's a squared term, so it looks like I've got positive x squared. There's an x term, there's an x term. Combine those and get negative 3x plus that 8. Now, on my next example, sometimes we got to distribute before we can get working with it. So I'm going to distribute that 0.5 to everything. So I got minus 1.5x cubed minus 2.5x squared plus 4.5x minus 4. And then just go and get your like terms once again. So it looks like I'm going to have 6.5x cubed. Combine your squareds. Looks like I'm going to get negative 6.5x squared. Combine your x's. So it looks like I'm going to get 10.5x minus 4. Kind of like you did back in Algebra 1. My examples 3, 4, and 5, I just needed to review the distributive property with you and then foiling. So I'm going to click right through these. Distribute. Remember, when you distribute, you add your powers. So this really becomes 21x to the 4th plus 56x cubed minus 42x squared. And then stop. There's no like terms in there, so you can't combine anything else. I threw this one in there so I could review foiling with you. First, outer, inner, last. So I'm going to go 2x times 5x. I'm going to go 10x squared. Then I'm going to go 2x times negative 7 and get negative 14x. Then I'm going to go 6 times 5x and get positive 30x minus 42. Simplify your like terms, which will be your O and your I most of the time. So I've got 10x squared plus 16x minus 42. So there's where we are so far. I wanted to review with you how to multiply a binomial times a trinomial. It's like foiling. I'm going to take this 2x times each of these terms. Then I'm going to turn around and take this 3 times each of those terms. So if I take that 2x times each of the terms in the trinomial, it looks like I'm going to get 6x cubed minus 12x squared plus 10x. Now take that 3 through there, 9x squared, 18x plus 15. Combine your like terms, so there's a 6x cubed. Find your squared, so I've got negative 3x squared minus 8x plus 15. The reason I reviewed that a little bit, here in a little bit we go backwards when we factor, and here in a little bit how to multiply a binomial times a trinomial. That'll help us when we factor our perfect cubes. Now I want to review 2 more items with you real fast. Notice that I'm going to take 6x plus 5y times 6x minus 5y. Whenever we do this, remember your middle terms are going to drop out. This forms a difference of squares. So I'm going to have 36x squared minus 30xy plus 30xy minus 25y squared. Since everything's the same in the parentheses except for the signs, this simplifies to be 36x squared minus 25y squared. The reason I reviewed that with you, here in a little bit we're going to go backwards. So if you recognize it as a difference of squares, we're just right here with a plus and a minus, and then you take the square roots. The other little shortcut that we're going to have is whenever we have a quantity squared. I'd like for you to know how to do that part in your head without writing it out twice. My first term is going to be that first term squared, 49x squared. My middle term is going to be your first term times your last term doubled. So 7 times negative 5 is negative 35. Doubled is negative 70x plus 25. Here in a little bit, when we go backwards, if this happens, if the square root of the first term times the square root of your last term, doubled is the middle, then when we factor it, you take the square roots, put the first sign you see, quantity squared. Now, that looks like in 5 minutes that was section R-1. I kind of rolled through it so the video doesn't get long or anything. Now, I've got a lot of examples here, but I'm going to click right through them. Factoring overall is pretty dang easy. So, here's where I'm going to go first. The golden rule of factoring says take out whatever they have in common. So I'm going to look at my 5x cubed plus 15x. I spy that they have a 5 and an x in common, which leaves me an x squared plus 3. And then I'm done. When I look at my number 2, it looks like they have a 2 and an x in common, which leaves me an x to the 4th minus 6x squared plus 12. Same thing with my number 3. Don't panic when there's not a number in common. There's no number that goes into 4, 12, and negative 7 other than 1. So I'm going to factor out two a's. So I'm going to factor out an a squared and a b, which leaves me a 4b squared, because we factored out both of those a squareds, plus 12b to the 4th minus 7. So there's my first type of factoring. Look at it and take out whatever they have in common. My next little group is our difference of squares. Notice that my number 4 and 5 are difference of squares. I know each of these square roots, and there's no middle term. When that happens, we factor like this. I can go parenthesis, parenthesis, and a plus and a minus. I can do that on both of these. It doesn't matter if you go plus, minus, minus, plus, and then you just take the square roots. Square root of 25x squared is 5x. Square root of 36 is 6. So boom, there's your number 4 factored. Number 5 factored will be 7x's right there. 8y right there. And then you just factored that difference of squares. Now what I did on number 6, it's almost a difference of squares. We just got to take out whatever they have in common first. So once again, the golden rule of factoring. I'm going to factor out an x, which leaves a 49x squared minus 64. Now the part in my parenthesis is a difference of squares. So I'm going to go 7x plus, 7x minus, square root of 64 is 8, and then we have it factored. So that's our difference of squares. My next little block is my perfect square trinomials. Perfect square trinomials. These get tricky every now and then. It's a perfect square trinomial if you know this square root and that square root. So in this case it's 4x, in this case it's 5, and then you got to check to make sure this is true. That term times that term doubled is the middle. If it is, 4 times 5 is 20, doubled is 40. This factors into parenthesis 4x, whatever that first sign is, 5 quantity squared. My number 8, the square root of 36x squared is 6x. The square root of 49 is 7. 6 times 7 doubled is 84. So this factors into 6x minus 7 quantity squared. My number 8, it will be a perfect trinomial after we factor out the 2x. Because now I've got 4x squared plus 20x plus 25. This square root is 2x. This square root is 5. 2 times 5 is 10, doubled is 20, so it fits our bill. So I've got 2x times 2x plus 5 quantity squared. So guys, factoring is really pretty easy. Most of them you can just look at them and factor it. That's the same thing on my 10 through 15 here. Notice that all my coefficients here are 1. All my coefficients are 1. So when I go to factor this then, I'm going to attack it like this. Since I'm unfoiling this, I know I have to have an x there and an x there. Now your job, go find two numbers that multiply to be this last number that add up to be that. So I need two numbers that multiply to be positive 6 that you can make add up to be negative 5. Well, you kind of have two choices. I've got negative 6 and positive 1, and I've got negative 2 and negative 3. Now, remember one of our rules had to multiply to be positive 6, so this guy's out. So factors into x minus 2 and x minus 3. I'm going to jump down to number 12. There's no number in front of the x squared other than the 1, so I'm going to go straight to the x's. I need two numbers that multiply to be 15, 1 and 15, 3 and 5. Fix it up to where you can make them add up to be negative 8. So negative 3 and negative 5. My number 14, once again, my a value is 1, so I'm going to go x and an x. I need two numbers that multiply to be negative 56, so one's positive and one's negative. My choices are 1 times 56, 2 times 28, 4 times 17, 5 doesn't go, 6 doesn't go, 7 times 8. Find the ones that you can make multiply to be negative 56, but add up to be positive 1. So in this case, positive 8 and negative 7. Guys, I'm going to skip 11, 13, and 15 since those are overall pretty easy. I did put a 15b on there just so I can kind of keep telling you to take out whatever's in common first. So on my 15b, I'm going to take out, it looks like a 4x, which leaves an x squared plus 3x minus 216, 4, that'd be a 5 and a 54. And then that will factor down again. I'll have an x and an x. Two numbers that multiply to be negative 54 add up to be positive 3, positive 9, and negative 6. Now, I've been flying through this video. I will slow down on number 16. In your Algebra 1 days and your Geometry days and your Algebra 2 days, you factored these by frowny face factoring. It's kind of a longer process. I'm going to show you a shortcut to that. So follow along on this shortcut. What I'm going to do here on number 16, I just can't do what we've been doing, x and an x, because that doesn't give me 2x squared. So what I'm going to do is I'm still going to take my a value times my c value. I'm going to go 2 times 4 is 8. I need you to find two numbers that multiply to be 8 but add up to be 9. Well, in this case, 8 and 1. Now normally, don't do this on your paper, normally we would have wrote that, but notice that x times x isn't 2x squared, and 8 times 1 isn't 4. So here's our next step. See this 2x squared? I'm going to use the 2x out of that. So it's going to look like this. I'm going to write parenthesis 2x plus 8 and 2x plus 1. So notice I used the 2x there and there. To offset that, I need to divide one of these by 2. So find the ones that 2 could go into, and I'm going to divide a 2 right there. Now when I do this, I'm going to get x plus 4 and 2x plus 1. So there it is factored. A little faster method than frowny face factoring. If I got you a little confused, here comes my number 17. I'm going to go 3 times negative 10 is negative 30. I need two numbers that multiply to be negative 30 that we can make add up to be positive 13. So I'm going to use positive 15 and negative 2. When I write this now, I'm going to use a 3x. I'm going to go 3x plus 15, and I'm going to go 3x minus 2, but I need to divide by 3. Find the one that 3 goes into. It's that first one. Here it is factored. X plus 5, leave the other one alone, 3x minus 2. Now number 18's got a little twist to it. So I'm going to go 4 times negative 15 is negative 60. We need to find two numbers that multiply to be negative 60 that we can make add up to be 4. Well, those numbers are going to be 10 and negative 6. Guys, if you don't see them right fast, that's okay. Go ahead and say 1 and 60, 2 times 30, 3 times 20, 4 times 15, 5 times 12, 6 times 10, and then look at them. So now, these are the numbers I'm going to use. So I'm going to write this as 4x plus 10 times 4x minus 6 all over 4. Now, look at this real fast though. 4 doesn't go into 10 nicely, nor does it go into 6 nicely. So I'm going to break down the 4. Instead of trying to divide one of them by 4, I'm going to divide the first one by 2 and the second one by 2, because 2 times 2 is 4. Now when I do this, I'm going to have 2x plus 5 times 2x minus 3. So I had to break it down. I had to split that up a little bit. I'll do the same thing there on number 19. So 19, I'm going to go 6 times 3 is 18. Two numbers that multiply to be 18 that we can make add up to be negative 11. Looks like negative 9 and negative 2. I'm going to write this as 6x minus 9, 6x minus 2, all over 6. But notice that 6 doesn't go into 9, it doesn't go into 2. So I'm going to split up the 6. I'm going to think of 6 as 3 times 2. Now I'm going to have 2x minus 3 and 3x minus 1. You can always check these by FOILing them out. Now, what I'd like to do with you now, before I hit number 21 and number 22, the factoring of a perfect cube, this will be new to you, these factoring of cubes. So let me explain to you where they come from, and then I think it'll make sense when we get the answers. So this isn't on your class example sheet, but look at what I've got written here. I've got a 3x minus 5 times 9x squared plus 15x plus 25. I want you to notice a couple of things. Notice that this 9x squared plus 15x plus 25, notice it's almost a perfect square trinomial. Almost. The square root of this is 3. The square root of this is 5. But the middle term isn't doubled. The middle term should be 30. So whenever you multiply a binomial with what I'm going to call its almost trinomial, let me show you what happens. A binomial times its almost trinomial. I'm going to take 3x times everything in here. So I'm going to have 27x cubed plus 45x squared plus 75x. Now I'm going to come in and take that negative 5 times everything. So I've got negative 45x squared minus 75x minus 125. Now watch what happens. This is where the perfect cube comes from. 45x squared and negative 45x squared cancel each other out. Positive 75x and negative 75x add to be 0. I'm now left with 27x cubed minus 125. I'm now left with 27x cubed minus 125. A perfect cube minus a perfect cube in this case. Now, to go backwards of this, I'm going to think of 27 as 3x to the third. I'm going to think of 125 as minus 5 cubed. Now, compare this to this. We're going backwards now. Notice this binomial is simply that first term, this sign, that term. Now, let's pick on the trinomial. To get the trinomial, it's this first term squared. And then you switch signs. If we're negative here, we're going to be positive there. And then my next term is this times this. And then my last term is this thing squared, that last term squared. So then we're back. Well, I got you a little confused now. Peek at number 21. I've got 8x cubed minus 125. Both of those numbers are perfect cubes. So I'm going to think of this as 2x to the third minus 5 to the third. Once you have that, you're ready. My binomial becomes 2x minus 5. That's my binomial. My trinomial becomes this first term squared. So I got 4x squared. I have a minus here, so I'm going to have a plus here. Always the opposite. My middle term is going to be this times this. So I've got 10x. Then my last term will always be positive, and it'll be that term squared. So I've got plus 25. I got one more for you. 27x cubed plus 64. Once again, perfect cube and perfect cube. I'm going to think of 27x cubed as 3x to the third plus 4 to the third. I put them in parentheses so you can kind of see a term and a term. Well, here goes the factoring of it. 3x plus 4. My trinomial becomes that first term squared, 9x squared. I have a plus here, so I got a minus there. 12x plus, last term squared, 16. You'll know you're right if this is almost the perfect square trinomial of that. I'm just off right there in the middle. So guys, that is section R-1 and R-2. The assignment is on Math Excel. So if you missed this day, you probably don't have Math Excel set up. So get in and I'll give you your sheet for that and we'll get Math Excel set up for you. Good luck.